Hey, what's up, everybody? It's ET. We're at what season 2 or shelf 2, episode 11, and we are going to continue working on planning in Sokoban. So this is kind of an experiment for me. I am kind of merging what I'm learning in school and this game I'm working on and putting them together to do something cool in Sokoban. So, uh, yeah, I'm not sure if I should minimize that. I'll leave that up. Okay, go ahead and open up Unity. Hmm. So where did we leave off? I think we kind of we're building up a plan graph. So we're gonna do a graph plan search. And so what a graph plan search is kind of like a general problem solver in computer science. And basically, you give a problem in a problem domain logic language or something like that, and you just, as long as you can frame the problem in this language, the computer can solve it for you. So that is what I'm trying to do. So yeah, and here's the problems. So we have this cake. You can't really see it here. So I'm gonna go ahead and open up Visual Studio as well. And well, while it's loading, what I'm trying to do right now is not get it to work in Sokoban, just kind of visualize what's happening, because that's going to be my final project for my class. But I'm also going to use it to solve some problems. Class, but that's weird. All right, let's go ahead and get the Visual Studio up. I just saw it come up. I swear I saw it come up. Now let me just double click this one more time. Alright, so here we go. Aw, it lost its open this up again. Like, it doesn't like me. That's all I can assume it is. Resource not available, blah blah blah. Client, we're unable to automatically populate your visual. Oh, that's okay. Or should I? Yeah, I can re-enter my credentials. I don't mind doing that. I wonder if that was like the issue. Like, I haven't really been checking any of that stuff. Alright, so I'm signed in, everything looks good. Let's add some existing items, shall we? Let's add this whole folder if we can. Alright, let's just add all of this. No, not there. Man. Well, alright, let me ask. Did it actually make any additional files? If it didn't, I'm cool with that. Alright, it didn't. Alright. So we got cake. So domain cake, action, bacon, eat. Alright, cool. So let's go ahead and keep going with making the solver for this. So, oh, we left off on the parser, because that seemed really hard. So let's go ahead and try to open that up. So we got a PDDL parser. And it is, yep, far from implemented. And the PDDL reader, which is just going to take two names, a domain file name and a problem file name, and then it reads it, and it basically just uses the parser to read it. So, okay, there's going to be some stuff we got to do, and it's going to be complicated, and it might just be really boring, but I'm going to just have to, you know, trudge through it. Alright, so here we go. Open up the parser. I'm going to close everything else for now. Close all but this. And let's see how Eclipse is handling it. So we definitely have some keywords. So let's go ahead and see if we can't just copy this in some form or fashion. Alright, so parse. We're going to have these keywords. And it's going to hate a lot of this. Alright, so what I'm going to do is I'm going to replace this final with just nothing? I think that sounds good. Replace, let's just replace next. Just so I can see what's happening. Cool. Alright, string is fine. I might just replace string though. String with string. Let's go ahead and replace all of that. That sounds great. Protect it. Sounds great. Control KD. Everything lines up. I might just get rid of everything for now. Alright, this is where it's going to get tricky because we're going to try to pass in the class type. And the class type, I don't really know how to do this. Oh, and I was going to check on generics and stuff. Now it's all coming back to me and I'm not remembering. So, okay. Phew, this is going to be tough. So these hash maps could also be dictionaries, I believe. Dictionaries. And then we just make sure we use the generics. There we go. And we could just say new dictionary of that same type. String object. Okay, excellent. We can also, yeah. You see, this is rough. This is rough. Can we make a dictionary of type? Oh, it seems like that. Object parser. I don't know what that is. Is that something? Okay. Alright, let's do some boring stuff. Let's look at some documentation for C# and generics, shall we? C# generic. Generics. Yeah. .NET Perls. I definitely do like Perls. Alright, so that's a way to make a class with generics. So let's read about it. And I'll read it out loud. Generic classes have type parameters. Separate classes, each with a different field type in them, can be replaced with a single generic class. The generic class introduces a type parameter. This becomes part of the class definition itself. Okay. Oh, I see I went back to type. Okay, example. One amazing feature in C# is the ability to specify and use generic types. Uh-oh, I gotta go get some cookies. Be back. Sorry about that. Okay, so let's see. One amazing feature in the C# language is the ability to specify and use generic types. These types themselves contain type parameters which influence the compilation. Yes. So in this example, the letter T denotes a type that is only known based on the calling location. So, and we see this definitely in Unity when you're doing get component and you get the little triangle brackets and you get the component type, you know. Alright, so the program can act upon the instance of T like it is a real type, but is not. So, okay. Generic class constraints. The C# language provides ways for you to add more features to your generic types by reducing the range of types that can be parameterized with. This feature is only occasionally useful, so I'm not going to do constraints. Um, wow, I don't know what it's going into. It's like going into different languages, like Python and Ruby. Crazy. And let me just see what it says with types. Yep, that's how you get the types. Okay, and let me just see if there's a C# generics function, maybe? So here's a generic method. Like, how do you return of type? Function return generic. Something like that. How do I make... yeah. Oh, okay. So it's just T. That doesn't seem too bad. Let's try that. So exactly how I guess Unity handles it. Yeah. Oh, yeah, that makes sense, I guess. Okay, so that's how the parser handles type. So we're not going to worry about this here. Yeah, that's exactly how Unity handles it. My bad. I should have known that way early. Alright, so blah blah blah. We're gonna get a domain here. And here we'll get a problem. Oh, cool. That's so easy. So easy. Okay, so that's how you do generics. Pretty cool. All right, let's keep looking at the Eclipse. So I don't have to worry about that object parser right now, right? Let's see what this thing does. Okay, register. I have no idea what this function does. So register parsers.put. What's a parsers? Parsers is a hash map. Okay. Okay, and basically, I gotcha. It figures out how to make a... I think I get it. I think I get it. So it's registering... I think I get it. I think I get it. So... So basically we're saying, hey, register domain.class and domain parser. So basically we're linking the keyword and what is this thing? This thing is the class. Okay. So let's do that. So let's go back to parser. We're going to register some stuff. Actually, if you don't mind, I'm going to steal you. And I see you don't like your... Wait a second. Where do you exist? Whew, this is tough. So these are all the things this thing can parse. Okay, I'm slowly but surely getting this. So, okay, let's just look at this domain parser right quick. I don't even know exactly what I'm looking at. Is that a function? Is that a variable? Uh, yeah, let's take a look. Alright, so, yep, this is all just functions, 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 functions. This is just a... What is this? Oh, shoot, my Java's not that strong. Okay. Um, Private static final. So it's a static, it's a final, it's of type object parser domain, and a domain parser. So basically when you do this, we're gonna override. Okay, I see what's happening. We're overriding the parse command, and we're gonna do our own thing in here. We're gonna do this code. So let's just do that. So we definitely, this is what I really need. I don't need parser. I'm gonna probably just need problem and domain parser. Everything else, not so much. And I don't know if I need this register thing. I do like what's happening though. It's very interesting. I'm gonna kind of treat this like a subclass, I think. That kind of just, not really just extends this. Whoa, okay. Are we still in the class? Yeah, so this class is going to be internal. It's just going to be called domain parser. And it'll do stuff like parse. Oh yeah, it'll be public. I don't know. Yeah, public's fine, right? Public domain parse. And then we could just do stream reader. Stream reader. That seems okay. And somehow we just got to put in these types. So this is how I'm going to call this: type of domain and type of domain parser. I feel like we need just one more function up in here. Can I put like an interface in here? Parser, iParser, iParser. And so what this iParser is going to do is just say, hey, you need a public t parse t stream reader Is that all I have to say? And why are you so angry at me? Let's see, the modifier public's not valid for this item. Okay, so do I just say t-reader? Okay. Okay, and you're just angry because you can't return it. Okay. This is gonna be interesting. Is there a different way? Like, I see that's how that works, but I wonder if I could just say domain. I don't know. Is that okay? Is that still me overriding that? It seems so. But I guess the second I take this part off, Yeah, alright, so it needs that part. Interesting. Okay. Phew, tough, but understandable. Okay. Let's now make a problem. Let's go ahead and also, yeah, this looks fine. Except this is going to be a problem parser. And with that being said, this should only give us this, I guess? So we have a domain parser and a problem parser. I'm gonna just, yeah, I'm just not do what I gotta do with this. Okay. Jeez. Alright, let's just see what this does. You have a parser. You register all those things, which is fine. Get parser. Not too worried about that. Parse is what I want, yeah. Alright, so when you parse, what is this node? I'll figure that part out. Type is good. Type is just a class type. So it's going to return that kind of type, I believe. So let's go see what this crazy node thing is. What's this? This is Eclipse, so F3. So yeah, all node is all it has is a link to its next, so it's kind of a linked list kind of node with only one direction. So require next is symbol is symbol. There's a parse in here. Come on, jeez, this thing goes infinitely deep. And I should try to understand it all. Alright, I'm deleting this for now. And I just might delete it all for now. Whoop. We got our keywords, so that's great. So the good news is parser so you get a file, okay, and then parser, if you give it a file, it does this. If you don't give it a file, it kind of does this. So if it says if node equals null, return null. Object parser E. Okay. Interesting. Ba-ba-bum. So heavily reliant on domain. Alright, so let's just walk through this. If nodes equal null, return null. Otherwise you get a parser. Parser equals null. You don't know how to parse that. So here we go. Parser backup is going to get hash map class parsers.clone string object define, so all sorts of backup stuff. Okay, now let's get into it. So here's an object. Okay, so try this. Try to just say, hey, parser.parse node.this. So basically, do it again. I think so, right? Parser.parse. I feel like that's just this function, right? F3. Oh, right, it gets this kind of parser. And that kind of parser, I think, just refers back to this parser. Whew. So that is these object parser things. So basically, it's doing this now. The domain or the... It depends what kind of object it is, right? If object's null, then you couldn't parse it. Finally, let's try this. If it all worked, do this. Yeah, I don't know what all this is doing. Guess just like assigning the name or something to it. And then you can return object, which is what you need. Okay. Let's figure this out. I think I got this, maybe. You gotta have a node object though, and that's what's kind of killing me right now. This is a whole nother rabbit hole I gotta jump down. So let's go ahead. Let's make it. I think I'm gonna put this other code on the side there, so that I can kind of do both. All right, so let's make a new class. I think it's Control-Alt-C. Node. There we go. It's in scripts, I think, so that's wonderful. Namespace is going to be plan graph, I think. Is that what I named? I hope so. What are we doing everything in? Plan graph? Cool. Node. It's going to be public. And what are we going to get? We got public node next. So we got node next. This is what I want to do. Private node next. Next equals next, and then finally at the bottom here we can say public node next is just a get. I do that wrong every time. Get return next. Nice. Alright, so that's how we get the node. So require next, what's that do? Return to the node's next sibling or throws an exception if there's such. Oh, crazy. Okay. I mean, it makes sense, just let's see how we're gonna handle that. Require next. If the next equals, oh yeah, next, next equals null. So if there is no next, go ahead and throw an exception. Throw a new exception. What kind of exception? Format exception? Sure. Expected something after this. Ah. Is that a thing? I think so. Alright. I think I do a string format on this. String.format. And then this. How's that? Alright, so here we go. That's how we handle that. Require next. Don't know what's that purpose yet. Public bool. Boo. Bool. Is symbol. This can, I guess, take the... Oh man, we're gonna have to... There's gonna be another class, I guess, called symbol. Let's just see, shall we? Symbol. Yep, extends node. What do you know? That's fine, we'll figure it out. Why do I have the feeling this is doing more than I want it to do right now? I'm gonna look at the domain parser. So node as list, oh, as symbol, oh geez, so it does do all this symbol stuff. Alright, I'm gonna also look at, I'm sorry, I'm not showing you what I'm seeing. I'm gonna also look at what problem does. If I can find it. Literal, expression, variable, constant, term, problem. Alright, so we're gonna do the as symbol. What else do we also, as list, I'm doing this kind of blind, and I realize it's probably not the best thing to do. I can see you parsing the domain. That's cool.
I'm sorry, I didn't get that.
Oh, Cortana. Gotta parse the constants. That's a shame. And what else are we parsing? Oh, we got another one. An expression. Phew. Okay, that is gonna be a problem. I think we're just gonna have to start at the root, y'all. This is not gonna be easy. Okay. Yeah, this is gonna be crazy. There's a lot to do. It's gonna take me so long. Let's go. Let's start at the beginning. So man, I even have a file on this, but I don't think I have it on me. Do I? Plane graph. Distribute it. Logical code overview. Oh, is that it? Is that what I wanted? Here we go. I'm gonna have to implement some of this stuff, like a formula, an expression, all of this. I'm gonna have to implement. So I'm gonna go ahead and move this over to the right, and I'm gonna go ahead and implement this in C#. So hopefully it wouldn't take too long. Since it's just kind of me looking at other code anyway. So let's just go. And I'll try to always just kind of keep it around if I can. So I'm gonna do this stuff. Formula, expression, expression object. Alright. So let me pull that up. I'm gonna make some folders and stuff. I think that will be a little easier to maintain. Alright, so new folder. So this is gonna be util, I think. Let's just start getting this right. Plane graph. This is going to be, so that's just code unique to plane graph. This will be code to all planning. So okay, for planning, this is what we need. We got a domain. What else do we have in here? A problem. Step, a state, so yep, step, state, problem, planema. Alright, so this is pretty good, so that goes into planning. Okay, we're also gonna have util. Util is going to go into planning. Immutable array is going to be one of them. Okay. What else? I feel like we're gonna have to do the logic stuff in here. So let's go ahead and make a new folder. Let's go ahead and get logic. Let's add a few things in here. So I definitely know I needed to add the interface formula, but I'm gonna try to stick to C# conventions. So I'm gonna make a new class, and I'll just call this iFormula. And let's see what else we got. iFormula, iExpression. Add new item. iExpression. And a literal. So iLiteral. And here we go. Some abstract classes. So expression object. This one's going to be expression object. This is going to be what other ones we got? Boolean expression. Boolean expression. Definitely a good one. N-ary Boolean expression. N-ary Boolean expression. And let's just keep going. Existing item, new class. Conjunctions, disjunction. Conjunction, junction, what's your function? Alright, disjunction. So we got predication, negation, and negation literal. Predication. Negation. Negated literal. Let's go ahead and do term, constant, and variable. Term, constant, and I might have to figure out how to keep all this kind of naming. I'll figure it out. Okay. So we're getting there. Got constant, formula, expression, literal. I think we got all that. Let's just see. Formula, yes. Expression, yes. Literal, yes. Expression object, yes. Boolean expression, yes. N-ary, yes. Conjunction, disjunction, yes, yes. Term, yep. Constant, yes. Variable, yes. Predication, yes. Negation, yes. Negated literal, yes. Okay, that's looking pretty good. I don't think I need to use the substitutions in what I'm trying to do. And one of the utils I think is, or one of the IO, might just be this. Normal forms. Yeah, I'm gonna put my, I implemented this one, so class normal forms. Alright, cool. So not using bindings, Boolean, conjunction, constant, disjunction, expression, expression object, formula, hash bindings. Yep, that all seems pretty good. I know you can't see what I'm seeing, but yeah, okay, so that's the logic. And finally the IO. So I'm going to go ahead and add that as another folder. IO. And that's kind of what I'm working on right now. PDL parser, PDL reader. I don't think they're really the same thing. Node is going to be part of this. But maybe it's back. I'm just going to keep restarting it if it goes down. Okay. Constants I got. Expression I got. Okay, this, and this can all go in plane graph. Is there a way to like change the namespace here? I guess not. That's okay. Alright, so I'm going to close all documents. Just open these suckers. Yeah. Plane graph is perfect for all of this. Plane graph, plane graph, plane graph, plane graph, plane graph, plane graph, plane graph. Great. Okay, let's start just here at the bottom. I think I got these two, so I'm going to delete that. I'm gonna go ahead and delete these two. I showed them to you, but there. Are they gone permanently? I don't know. Who knows? Uh, so, okay, here we go. Domain, problem, state, and step. I'm going to open them all up. These are not plan graphs. These are going to be under planning. So, planning, 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 save, 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 save. Okay, let's go to the util. I'm going to be planning that util. Oops, should have closed everything. Close everything first, then open everything. I think I got it. You will be, yeah, planning.logic. That sounds great. Planning.logic. Planning.logic, 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 save, save, close, 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 save, close. Oh, we got a few more. Planning.logic. 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 Save, close, save, close, save, close, save, close. Alright, I'm gonna work up this branch. So, easy enough, I think. I'm gonna open up Eclipse on the other side. I'm gonna open up what I'm working on, which is formula for right now. This is how I should have handled it the entire time. I think I'm just copy all the code and work on it from there. So Edward Thomas Garcia. So I'm porting this code. Oh, there's a comparable. What is a comparable? Oh, I think that's okay. I don't really know what C# does for compare to. Compare to. Yep. Cortana. I comparable. So that's what we gotta kind of do. Formula I comparable. Shoot, it said it had it, I just didn't do it. I comparable formula. Interesting. So to do this, I don't think I'm gonna just take this out for right quick, delete this. I wonder if I can like, yeah, let's just leave it all in there for now. I don't think I need that part. I'm gonna comment that out. Public override. Override. Yeah, I don't know. We'll come back to this. What did I? That's not what I wanted to do. That's not what I wanted to do either. Tracy. Okay, Casey. Alright. This is an interface. So I'm going to try to leave all the case the same for now, and then I'll finish it up. Alright, so substitution. Oh, you need a substitution. That's okay. We can totally add that. New item, new class. Substitution. Cool. Okay, and what do you want? Well, let's make you valid. So public I formula. Why aren't you valid? Let's see how interfaces work. Maybe some .NET Pearls can help us out. Yeah. Oh, you just say what it is. You don't actually say whether it's public or private or whatever. Okay. Whatevs. I'm cool. Now what? Yep. I gotcha. I gotcha. I believe it. Oh yes, got one down. Two down. Three down. Four down. Oh, down. Nice. Oh, I see the confusion now. Whoa. Yeah, something like that. Is that good? Yeah, that looks good. Okay. Now, how do I handle this guy? Defines a generalized comparison method that is... Okay. How do we use this iComparable thing? Alright, so all we do is just say public int whatever. I'm cool with that. I think we're just gonna have to figure it out. Yeah, I have no idea. I think in the first real class we'll have to do it. Let's see, C# interface that implements interface. Yeah. Okay. Not what I wanted to do. We'll figure it out when we get there. But what I want to do is, I think I'll just leave the code there as is. Yeah. Perfect. That's how I want it. Okay, so we got formula. Slowly but surely we will get this. Alright, so if we're working in our list here, we got formula, let's go to expression. I think that's how I want to do it. Alright, let's go to expression. Expression. And expression is going to implement formula, I guess? Okay, well, I also see that now. Under iFormula, I think I just made it formula when I should have just made it iFormula. And then you're like, what are you doing? I think interfaces here is a little different than the one in Java. So I won't do it exactly. What? Oh, it's iExpression. So that's going to be a little tricky. And I think for now, I'm going to make them just like formula. And, oh good, I even renamed the interface. Excellent. Once I finish this, I will try to remember to do that. So, Boolean, 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 impose. I don't think I have mutable state. Where would mutable state be? Mutable state is just in planning itself. So go ahead and add a class, mutable state, and just take out this. Excellent. You got it? Good. And for now, I'm going to make these all iExpressions, but I will have to change that as we're implementing everything, just because it's going to be a pain in the butt otherwise. Yeah, and that literal. Let's go ahead and just make you literal. I had you open, so maybe you didn't do it. Okay, so literal. And you are not final. Yeah, I know you're trying to do that here, but interfaces just really don't do that. Or, yeah, I don't even know what you're trying to do in here. Yeesh. Alright, let's I'll figure this out in a bit. Because I know he does this several times in his code. And it might just not be a C# thing. Alright, good deal. So maybe, I know we got tons of errors, but we'll fix them. It's the plan at least. Oh, mutable state is not very access friendly, so let's go ahead and make that more access friendly by making it public. As I delete the rest of the publics. Alright, oh, and I got, what, one too many parentheses opens or something? Or not enough parentheses open, that's also a thing. Yeah, that seems good. Okay. That all seems to be working order. Let me see what he's doing here. Okay. So when he tries to do this literal, he's going to say public static literal true. And so he's like, okay, this literal is going to just be this new literal. It's going to override everything basically. I'd almost make this like its own class. Anyway, we will look at that in a bit. So we have the literal, the expression. We could jump to literal. That way we just get all the interfaces out of the way. I like it. Let's do it. I'm gonna close this expression, this I expression. Actually, close it all for now. Close all. And if I rename this F2I expression, oh well, I tried. I expression. Alright, good deal. So hopefully formula is now just formula, yes. And literal should just be literal. And we're just going to copy all this heavenly glow. Alright. You can do that. Okay. Good to know. I tried doing that with expression and you kind of freaked out on me a little. Did I just write override here in the front? The modifier is not valid for this item. Hides inherited. Okay. Oh, good. That was the only thing that it was hiding. Good. Okay. Good. So expression. What are we gonna do with this expression? Hides, right? I have no idea what this means. Oh, you don't do default, right? Um, Gosh, let's learn more about interfaces. I know a little bit about interfaces. But I'm gonna look. Alright, so an interface, that's it, using the interface. How do I actually, yeah, that's the interface. Okay, interface just has a method and then you just implement that. Okay, interface, here we go. That's like for some values. But then that's you using it. Yep, so interface is not as robust as the one in Java. So we're gonna, these like default values, we're just gonna have to put in some kind of either like abstract class in between, or we'll figure it out. We'll figure it out. Sorry, just thinking of how I'm gonna handle this. I'm gonna make sure I have the override keywords here. Things I gotta do. Man, this is really should be an abstract class almost. Almost. Oh, it's gonna do that somewhere, but I'm gonna miss it, and that's okay. Okay, so this should almost be an abstract class is what I'm seeing, but I'm not there yet. Alright, so this is all the interfaces done, and we didn't really do anything new with literal. I might think of making an abstract class, I'm just not there yet. What am I doing? Let's go back to, yeah. Let's go back to our image. So we did formula, expression, literal. Let's do the expression object. So here we go, expression object, expression object. Here's the comment. I definitely ported it. Please make sure you say who you're extending, which is expression, and then public. What are you? Implement interface. Yeah, how do we do that? Implement interface. Oh lord. Sorry. Let's back up a bit. It's gonna be a public abstract class. Can I get rid of some of these things like this? we gotta implement this one. So basically we're gonna say if other instance is formula, go ahead and return equals formula other substitution dot empty, and I don't know what that is. Else return false. You don't really know what that is, right? Yeah, you don't have anything referencing that, but if you think you know, I won't fight you. There we go. I got it out of him. Let's make this a property, a field maybe? Maybe a field. Okay. Yeah, I'm cool with that. So what do you want me to do? Implement interface, interface abstract. I guess so, right? Like, what happens if I don't do this? So you can't really... Let's see what Google says. Abstract class implement interface. Yeah, there we go. That's the answer I wanted. Unlike Java, in C# an abstract class must provide implementations of all members of the interfaces that are listed in the base class. However, an abstract class is permitted to map interfaces onto abstract methods. However, an abstract class is permitted to map interface methods onto abstract methods. Exactly, and that's kind of what's happening. Except this formula thing, which, geez. I don't know. I don't know how we handle that. So we have expression, who has substitution, and then we have formula, who has substitution. So the formula substitution returns formula. No. And then so formula and then expression, who also has a substitution. And so if you do it on the expression level, it returns the expression. If you return it at the formula level, it'll return a formula. Because formula, and let me just make sure, formula can be a term as well. Yeah, I gotcha. Or an expression. So, so you really do need to have your own substitute here. But you can't override or virtual, right? Virtual is not a thing here. Interface override C#. Alright. Interface, IFU. Implementing another interface C#. Okay, you can't do this. Any class can implement any interface it has access to. Why would you want to do this? Bear in mind that by declaring an interface inheritance, you're specifying that anything implementing B also has to implement A. So you'll get classes implementing interface A anyway. Right. Alright, so where am I running into the problem? So like if I did say new here, when I'm in my expression object, yeah. We definitely probably want to... Can I just abstract this out? What's up? Yeah, we're just gonna throw not implement it, I guess. I hope I don't run into that issue though. I don't know what to do there. Okay, anyway, I'll stop messing with that. Let's just move forward. Okay, we got this abstract class. It implements the other thing, so that's good. So So where are we at in our drawing? Now we need the Boolean expression. Oh good, it does nothing. Alright, so sometimes that's a little weird, but at the same time, just happy to have it. Oh, sorry. Before I actually like implement it or do anything, let's go ahead and say public abstract class Boolean object. You don't do anything, so I won't even argue. But you do have a comment, so you know what? I am going to add you. And put my name on it, because I did something. Okay, that's great. So we definitely got the Boolean expression, that was easy. So we're coming down, I'll just keep going down this branch. N-ary Boolean expression, N-ary Boolean expression, N-ary Boolean expression. Alright, here's a little bit extra code we gotta work with. Okay. So here's the class. I'm gonna just go ahead and copy and paste all of this. Oof, this looks like it's gonna be fun. Can we just use... Perfect. You don't like the word operator. Let's see if I can just rename you. Okay, we're just gonna have to... Yep, sorry, just doing some replacing because you can't use the operator keyword in this thing. And that looks good. Great. Alright, so immutable array, length. Okay, so now we gotta start looking at immutable array. So we're gonna take a detour, go to immutable array, detour over here, immutable array. Okay, and what is this gonna do? It's a pretty big one. I think this is sealed, maybe? Immutable variable C#. Read only. Okay, I can do that. think it should be T maybe? Yeah, there we go. Alright, so where we got E, we gotta make that T. Yep. I enumerable maybe? T. And this will be type. But honestly, you should just do it here. Ding, ding, ding. Oh man, I love me some Command and Conquer. Alright, I'm doing something incredibly wrong here, it looks like. Immutable array. Okay. Maybe I just return this. Oh yeah, we got the enumerable T, right? So we should be okay. Collection dot I was to say list T. Hit F12 on list. List extends enumerable I collection. Okay, let's do I collection. Because I'm sure this and Java do a lot together. Dot count. There we go. Perfect. Alright, so I collection dot, is there a 2 in array? Maybe it's like this, 2 array. Let's see, 2 array as, is there any kind of array? Okay, right quick, C# I collection array. Yeah, let's see. Okay, that sounds good enough. I like that answer the best. There should be a 2 array function. Call. Interesting. I don't see it, so let's do it the other way. Array equals T collection dot count, or length basically. Where did I screw up? Cannot implicitly convert system array to T. Mm, I guess so. Hmm. Oh, did I just forget to put new? That that's silly. Oh man, alright, that's all I forgot to do. So we're gonna make a new T array of length, and then all we're gonna do is just say, hey, array dot nope, collection dot copy to array. Zero. And I think that's how that works. Okay. So that's great. We got that going. C# override abstract method. Bloop. So, okay. Oh, this is a mutable array. You're not actually extending anything or doing anything, right? Iterable. I think it's enumerable when it comes to this. Implement it through array? I don't even know what that means. Alright, so I'll just let it go. So if other is immutable array, what? T? Okay, object other array is going to be immutable array of T. Other. Oh yeah, that I understand. I think this should totally be a T. Alright. If array length is equal to other array length. Yep, I'm still following you. For int I, int array length. Yep. And this is going to be length. We're going to go with equals. And yeah, that looks good. Hash code, probably something very similar. What are we overriding? You say at override, but you're just implementing iterable. And iterable is a Java thing, so I'm not too worried. Okay, but I'm gonna go down to how do you make an indexable class? That's the other thing I wanted to figure out in a C# index class. Something like that, right? Like using indexers in class, right? So int index. So here we go. We got temp records. Where's our indexer? Class temp record. Oh, it's just a part of the property. Public float this. Okay. Interesting. And I won't do the set, basically. I'll do the get, but not the set. Interesting. That's kind of how I thought I should have done it. I don't think I need the hash code. Well, let's see. We'll hurry up and do this one. Fine. Let's not put these things in it yet. Okay, I am going to put that thing in, and we're just going to replace these instances. Hash code, hash code, hash code, hash code, hash code, array, array, array. This is going to be the actual length of the array. And yeah, I figured you'd rely on the hash code of others, and we just don't have it. So I'm not worried about it. Let's not worry about the hash code. The length and the array are fine, so that's good. And the equals is good. But it really should just override the other equals, so what I'm thinking really is override equals. And this is how we're really going to do it. You can call you other. Like it. I like it a lot. Alright, good deal. Yeah. Perfect. Yep, all that's okay. Excellent. So we got contains index of. Um, we're not gonna do the 4 each, so I'm just gonna skip that. I'm gonna skip this, and we'll just do it this. I'm not exactly sure if that's correct, but feels right. Okay. So, man, that was a little tough. So we got the immutable array. What were we working on? I think we were working on n-ary. So, okay. This should totally be just like length, or length, right? Oops, that length. I totally forgot. What should this be? Like, how do you get the length? Oh, you're public. That's why it works for you. Yeah. Just stay public. Or, nope, better yet. Private. And... But you see, if you're read-only, you're doing exactly what I wanted you to do anyway. Okay, yeah, that's fine. There we go. Okay. Yeah. Okay. This is looking good. Looking good. N-ary Boolean expression. Oof. I totally forgot how this works. C# undefined arguments. Undefined number of arguments. Or variable number of parameters. Yep. Params. That's what I gotta do. Params. And this is how I'm gonna handle it. Expression like that, I guess. Doesn't like something. Didn't do something right here. Oh, we still gotta name it something. Arguments. Yep. Oh, was that me? No, alright. I think the way you handle this is this opper and new immutable expression. Oh, okay. New. Well, I'm pretty sure that's what I want to do. Alright, if that's how you want to roll it, that's how you want to roll it. Alright, good deal. Alright, that's looking pretty good. Yep, let's do the equals. But like I said, I think for the equals, we definitely know what we gotta do. Maybe we don't. Thought I did. Oh wow, I see I renamed a bunch of the stuff, which is okay. Take out the hash code stuff. Take out, not take out, but basically redo this. Take out that override because we're going to do our own override, toString, and we're going to just delete this stuff, and yeah, that seems fine. I don't think we're really overriding anything here. It'll tell me if I'm screwing something up. So we're supposed to have arguments, I guess? And arguments is here, yeah. So we got arguments as an expression. Oh, for each. How about that? Oh good, it still keeps it. Okay, so that looks pretty good. Yeah, you overrode the equals, but you didn't really say anything about it, which is okay. I'm not really doing the hash codes. We overrode that, we overrode that. Here we go. Expression. I screwed that up. That was my fault. Oh, this would have been so good if I didn't screw all that up. But all the other code seems to be working fine. I didn't like actually test it or anything. But I mean, if the logic's there, the logic is there, right? And here we go. Instead of an array list, we're going to just use a list. And we're going to do for each. Man, I want to play all these games again, like Streets of Rage 2, or Mario 64. Oh my gosh. Okay, let's figure out what's happening here. So, for each argument and arguments, can you get the class? I really want to understand what's happening here. Oh my gosh. Alright, we are going to see if you can get class is assignable from the argument that get class. Alright, so what if I didn't do that? uh, I think you're just trying to say, is argument an n-ary Boolean expression? And if you are a Boolean expression, go ahead and get your arguments. Except this is how we're going to really do it. Yeah, there we go. And arguments.add. Is there a toArray function? Oh, there was? Let's see, dot toArray. Oh, dude. Sweet. What if I just don't do any of that? Awesome. Hi. Okay, so that's looking pretty good. Okay, picture book. So we got this whole tree. Now let's do conjunction, disjunction. If I can get most of this picture done today, I'll be the most happy. Uh-oh, is this our first non-abstract class? Maybe. So let's say public static read only string. Yeah, I like that the best. You can use planning util, yeah. I think we call this base. And I think we do this here. Oh. Yeah. And if I really want it to be kind of snazzy, I'll do it like that. That seems good. So this is how I handle this. Params, expression array, arguments, and like we did earlier, and just delete it like that. Okay. Is this an override? I don't know. Public conjunction substitute, yep. I think we're gonna have to do bindings. Is testable. I'm gonna say true. That looks good. So we're extending this abstract function, so it's not really telling us that we're like hiding anything. It usually would, I think. We'll try to get this right. Okay, it's looking pretty good. Blink, 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 blink. Jeez, there's a lot of codes and stuff in here. Yep, we're about to work on that. I'm going to go ahead and generate this method, and we'll, of course, work on it later. U conjunction flatten. What's wrong with it? Can't convert conjunction to an expression. Oh, what? I didn't extend. 12. Oh, come on. Is that what happened? Oh, expression object. Okay, all very good stuff. Let's do, yeah, I like it. Let's do virtual abstract override, right? Override, override. Oh, something's happening. Yeah, let's get the easy ones done first, and then we'll look at the hard ones. Okay. What am I screwing up? Alright, type must return an expression. So if I go here, there is no talk of substitute, right? Oh, that worked. So is this part. We don't have a disjunction stuff yet. And substitute. Return type must be expression to match the expression object substitute. Alright, so here's expression, expression object. I know you can't see what I see. Okay. If I go to expression object, Alright, sorry, just looking. Alright, I gotta figure out how to do this the correct way. If I don't do this, are you gonna try to tell me substitute? Yeah. So did he do it? How did we do the other one? And what's the other one? Is ground? I think that's the one with the negate. No, where's his ground? I know I saw his ground. Maybe it's not here. So if I go to conjunction, yeah, it's not there. Interesting. Maybe it's in the abstract. Oh yeah, it's in the abstract, so should not need it again. Okay, yeah, for sure, override that sucker. Can I override? Oh, that's no problem. Let's do that. Canary comes from Boolean expression, which comes from expression object, which, what are we overriding? The equals? Yep, here we go. Alright, let's try to fix some of this stuff like this. It's gonna be using planning for sure. Okay, good. What else needs? I guess let's just comment this out for now. Alright, so what else who else is having a problem? How do we build? Build solution. Yep, I understand. There's gonna be a lot of problems. I don't mind it. Ah, yeah. I'm gonna figure this out. We got it. We got this. Domain. I think domain's in planning. It's in planning, right? Yeah, that should be this guy, right? Oh, huh. Wonder how that got changed. Oh, and it shouldn't be in plan graph. It should totally be in planning. Oh, I see what happened. Oh, did I do that to all of them? Planning, planning, planning. Okay, no, I think it was just that guy. Alright. Closing all. Let's rebuild. I think those two things we're just gonna have to figure out in a bit. Immutable array, yeah, we can definitely figure you out. Use the planning utils, and you can use planning logic. And you are good. Okay. Alright, immutable array or constant is screwing something up. I think you're okay. You're not okay. I'm not worried about you right now. Let's just build. Alright, PDL parser, not all code for now. Gotcha. There we go. That's how we shut it up. Yep. Okay, cool. We are getting there with the errors. Errors. All right, let's do disjunction, and then we'll come back to conjunction, see if we can fix it all. So disjunction is going to be very similar to conjunction. Let me just check my timer. 2 hours, 12 minutes. Alright. Probably cut this out in a bit. Phew. Porting code. Porting from Java to C#. Fun stuff. We're gonna go read only. String. Yeah, sounds good. We have to include the planning util. We're gonna make you base, delete you, get you, down here, control KD, perfect. Keep it going. Instead of that dot dot dot, how C# handles it, it's param or params. This is gonna be an array of arguments, and that's it. So we'll just do base that, delete that, colon this, delete all this, control KD. Oh, maybe this is this. Did I do something wrong? I'm not actually doing anything here. You should be an n-ary Boolean expression. Yeah, I get you. Okay, cool. We'll look at that warning in a bit. This basically is okay. So all these overrides we are going to do just in a different way for each in arguments. Okay. Yeah, alright, so far so good. Let's keep it going. I'm gonna replace these with bool. Replace. Oh, I just hit replace all. That's okay. Better undo that. Maybe I shouldn't. Oh yeah, I really shouldn't. Find next. Bool, bool, bool. Next. Okay. That's how I really should have done it. Okay. I don't think you have the word illegal in here. Oh, did I make all the text smaller? I didn't mean to do that. Okay, who are we missing? A lot of stuff, because we didn't put the override word. So let's go ahead and start putting the override. So there's one, 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 there's one. Oh, don't worry. We have another function for you. Okay. Okay. So I'm gonna just make this expression, and let's go back to Binary Boolean expression. I think I got everything I needed to do so far. What? Oh yeah, I did change that. Alright, so length, length, length. Okay. Fixed all that. Oh, so close. What do we got? These things don't do what they're supposed to do. That's fine. Conjunction is missing. Hopefully just that substitute function. Disjunction is hopefully just missing that substitute function. And yeah, we need to figure out how this is actually going to work. Really? You just won't let me have it, huh? Okay, so if we go to node, I think this stuff in the I.O. So node's gonna have some junk in it. And like I said, I'm probably just copy and paste it. I'm probably redo some of this. Yeah, while we're just copying and pasting stuff. Symbol. Okay. Oops. Symbol. Edwards. Alright, so symbol is going to just do this stuff. It's going to grab this. It's going to be read only. You can be string. Don't know what you want from me. Okay. Okay, that seems all fine and dandy. Yep, great. And you should not be in this. You should be in IO planning.io. And I hopefully node. Oops, that was me, right? All right, cool. Hopefully nodes in kind of the same thing. Planning. All this should be in planning IO. And I might have screwed some stuff up doing that, but it's where it needs to be. Okay, so we only got two more things to worry about, and that's this whole how do we handle substitution. It'd be nice to do this. But then you're like, hey, what about public expression? Is it, who am I getting this from? You should tell me, right? Expression object, right? So, can I do something like this? Public expression, expression object dot something like substitute. You won't let me do that? How about like this? Like, I saw you kinda do that here. It wasn't the exact same thing though. Under expression. Nope. Under formula? Under literal. Crap, where was it? Expression object, I guess. Yeah, this. I guess I just don't like you there. Or maybe I do it like this. But can I have multiple of them is the other question. Nope. How do I handle this? Maybe I don't. Maybe I do. Hmm. C sharp, inherited class function or overridden function return type. So I guess it's by generic, I guess. I got the best answer. Oh, C sharp does not return type covariance. Return type covariance. C sharp, Java. Yeah, so we don't have the covariance. Uh-huh. Yeah, that's the problem. But it makes sense. Just reading this. But I understand now. But basically, the answer is so okay, let's see what they're doing. They're getting public class alpha with the generic where T alpha T. Where virtual T do something. Blah. Oh, that's so. You basically specify that T is already alpha T. Interesting. And then when you do beta, you just extend alpha beta. Interesting. Huh. That is so zany. like it says in the thing. So let's see if we can start it from here. Where T is formula T. Is that what you told me to do? Yeah, that's the part I don't like, is the yeah. Darn generics and their thing. Alright. Screw it. I'm done. I don't really want to do that. So to like just make this easier on my sanity, let's just go ahead and delete whatever we're doing here. We definitely want to override this. And guess what? We're just going to make it an expression. And same thing over here, disjunction. We're going to have to override this. And it still doesn't return the right type. So we're going to just make it an expression. And we're going to build. And OMG, there are no errors. So awesome. Phew. I know, I just can't stop, right? Like now I just want to do this normal forms right quick, and that's the one I worked on a bit myself. So I can actually be an official author on this thing, so that's cool. And let's go ahead and just copy everything I did, I guess. It's tons of lines of code, so this may take forever to look through. We'll see how far it gets. Oh my gosh. Alright, so let's just go through it real quick. Is literal. Expression is literal. Alright, that was easy. I like these easy ones. Is clause. Is n-ary boolean expression. Oh, I did a lot of these too. For each. Okay. So all this first stuff's pretty easy. So I'm just gonna keep going until I run into a big problem, and then I'll start talking again. Oops, I already lost where I'm at. It's okay. I'm just guessing. Okay, so all these instance ofs can be replaced by is. Expression argument. Oh, we don't have negation yet. Alright, so we definitely... Man, we gotta work on negation next. Let's go. Detour. Negation, please. Negation. Negation. Yeah, so I'm just saying port it if I didn't really do any work except do just what I'm doing, pasting everything and converting it to C#. So it's going to extend Boolean expression. Okay, public read only expression. Okay, great. Trying to get through it, trying to get through it. We're not going to do anything with hash code right now. Yeah, I don't know what we're trying to override here. Let's see. Boolean expression extends expression object, which extends expression, which extends formula, which extends comparable. Oh, I see. But so Boolean expression is an abstract class. Expression object is also an abstract class. Let's put it here. Because I really don't have. Let me see. Because this has like a function in it that I can't really implement. So I got to extract it here and on term. So in two different places. Expression object. So wait, formula is interface. Oh, but I didn't make it extend comparable. Formula. That's what I forgot to do. So now if we actually go to expression object, alright. Good enough for now. And now you can actually override it though, right? Because it's an expression object. Oh, but it's not virtual, so make sure you make it virtual. And now we can go back to normal forms. No, where are we working on? Negation, right? I don't know where I'm working. Crud. Yeah, this is where I'm working. Awesome. Alright, equals is base compare to. Alright, good deal. Okay. Yeah, it makes sense. Override. Override is ground, is that. Yep, override that. Expression substitutes. Override. Okay. Let's get in there. Override. Override. Boolean is imposable. Okay, everything's looking good. Okay, negation. Negation's done. Now we can go back to normal forms, now that we have negations. But negation should have what? Negate arguments, right? Oh, that should be under yeah, I don't know. If I go back to normal forms and I go to, what function am I looking at? Move not inwards. Move not inwards. Right, that was part of n-ary Boolean expression, right? Let's protect it. Protect it. What does protect it mean in Java versus C#? Java protected method. Alright, privates hides from other class within the magic public, exposes class outside of protected, is a version of public that okay. So protected's more like, it's not really protected. It should be something else. So just for that one, I'm going to go ahead and, instead of protect it, we're going to make it internal. Internal. I think that's the one. So back to normal forms. There we go. Let's go ahead and use planning utils. We're going to say this is instead of an array list, we'll just use list. Alright, and then for each is going to be like this. Add is going to have a capital A. Instance of is going to replace what the keyword is. Get array is something I think it's one of my private functions, but it just doesn't see it right now, so I'm just going to go ahead and be okay with it for now. Okay. Just converting for eaches and instance ofs to in to is and in basically. And list are not array list, but just straight up list. List like that. Yep, here we go. Another in for each. And here's an add. Instead of size, I think it's count. Get array still not being seen. That's okay. I'm gonna go see if I can do this a little easier. Array list to just list. And we're just gonna go for each one. List, 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 list. Oh yeah, we're gonna do that a lot, so. Oof, yeah. Talk about a lot of times. There we go. Working back up, we're gonna go page down a few times until we see some errors. Here we go. We're gonna take this and we're gonna make this in. Replace, 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 replace. Where are we at? No, we don't need to do that one. Replace, replace, replace. Skip that one. Replace, 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 replace. Replace, 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 replace. Okay, done. And here's the other thing we gotta like kind of look for. Instance of, and we're just say is. Go replace, 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 replace. Okay, that one was pretty easy. Alright, now we should be pretty close to getting done. So yeah, some of these for eaches and some of these adds. For each, and add. And of course, these counts as well. Okay. Well, it's a little tedious, but man, it's not too bad considering. Alright, just going through it, capitalizing some of the function names because of the different naming convention. And I think it's going good. We're just going through it, right? I think you just do it like that, right? Hmm. Alright, what am I missing? Oh, nice. Got a few more. Boolean, Boolean. What else we got? Oh yeah, no, dot. Okay, yeah, I can fix that too. That's how you handle that. Remove at. I think. Whew, that's it, right? Wow, we could almost do our test. I just don't know how to do a JUnit test in C#, but maybe it's something I should be looking into. Yeah, that wasn't too bad, converting all of that. Oops. Okay. Gosh, that was a lot, so I'm gonna just leave it like that for now. It builds, everything's there. I don't even know if Unity's still in the background. Maybe, maybe not. There's gonna be a lot of changes back there. Oh my gosh. Yeah, it's all there. Okay, cool. I think really nothing changed there. We'll go ahead and open up source tree, and we'll commit this. Oops. I don't know what happened. Oh man, but sorry for the long just coding part. There's just a lot of initial work that has to be done, and probably I didn't have to stream this, but you know what, I'm just gonna keep it for my record. So here we go. So that's everything that's kind of moved. Here's everything that's kind of existing. What's my branches look like? Initial commit, okay. Commence initial implementation, or porting, planning, what's this called? Namespace, package slash namespace to C#. Start it with planning.logic. And what else did we do? Util. We didn't really do much with it. Still need to do planning.io and more planning just in general. Okay. I'm pretty good with that. Let's just do everything. I don't think there's anything I need to really worry about. Okay, I'm cool with everything. Let's commit that. And I'm done. Alright. Good. Alright, everybody. That's it for me. I will do this next time. And we'll finish the rest of these things and should be good. 3 hours. Jeez, yeah. It's been a long time. Bye, guys.